Hi there. Welcome to the edge of everything we know, where the universe whispers its most unsettling truths into the infinite silence. You've arrived at the Afterstory, a place for minds that find comfort in cosmic insignificance, where the vastness of space becomes a quiet companion, and darkness is not merely the absence of light, but the very fabric of existence itself. Here, we gaze into the void and allow it to gaze back. We contemplate mysteries so immense they make our earthly concerns dissolve like morning dew. There's a strange calm in recognizing how small we are, how brief our presence is, and how vast, cold, and indifferent the universe remains. If these reflections resonate with you, consider supporting the channel by liking this video and subscribing. Let us begin with one of space's most unsettling mysteries, the Fermi paradox. Our galaxy contains 100 to 400 billion stars, many with planets, and the universe holds 2 trillion galaxies. Even conservative estimates suggest billions of potentially habitable worlds have existed for millions of years longer than Earth. Where is everyone? The silence is deafening. Perhaps we are truly alone, the only conscious beings in an incomprehensibly vast universe. Or perhaps something prevents civilizations from contacting us. The Great Filter theory suggests some catastrophic barrier exists that destroys civilizations before they can communicate across the stars. If this filter is behind us, we're extraordinarily lucky. If it's ahead, our doom is inevitable. Or perhaps civilizations do exist, but remain deliberately silent, hiding from something in the cosmic dark. Radio signals we've sent into space, announcing our presence, our location, may have been a terrible mistake. We've been broadcasting our existence for decades now, and the signals travel forever through space, unretrievable, potentially alerting predators to our presence. We are children shouting into a dark forest, not knowing what listens. The universe is dying, slowly and inexorably. The second law of thermodynamics decrees that entropy, disorder, must always increase. The universe expands, and as it does, it cools. Stars will eventually exhaust their fuel. In about 100 trillion years, the last stars will flicker out, leaving the universe in permanent darkness. The degenerate era, when only black holes, neutron stars, and dead planets drift in the void. But even black holes aren't eternal. Through Hawking radiation, they slowly evaporate over googolls of years. After 10 to the power of 100 years, even the most massive black holes will vanish. What remains is the dark era, an infinitely expanding universe containing only sparse elementary particles drifting apart, separated by distances so vast that no signal could ever connect them. Temperature approaches absolute zero. No structure, no complexity, no thought possible. This is the heat death, the maximum entropy state where nothing can ever happen again. The universe will exist in this state for literally eternity. Everything that has ever happened, every civilization, every thought, every love, every struggle, becomes less than a quantum fluctuation in an infinite ocean of nothing. We live in the universe's brief moment of complexity, a cosmic eye blink between the Big Bang and eternal darkness. Between the stars drift billions of rogue planets, worlds ejected from their solar systems through gravitational interactions, now tumbling through interstellar space in eternal darkness. These planets receive no light from any star. Their surfaces are frozen wastelands at temperatures near absolute zero. If they once harbored life, that life froze and died within years of ejection. But some rogue planets might retain subsurface oceans, kept liquid by radioactive decay in their cores, creating isolated ecosystems drifting through the void, life that will never see a star, never know warmth, existing in complete isolation for billions of years. Our own solar system could capture a rogue planet, its gravity disrupting orbits, potentially flinging Earth into interstellar space. We would freeze within weeks. Alternatively, a rogue planet passing through the Oort cloud could send comets raining into the inner solar system, an extinction event from the dark. We wouldn't see it coming until too late. Estimates suggest rogue planets outnumber stars, meaning the galaxy is filled with dead worlds, tombstones of failed solar systems, drifting alone through the dark forever. Some may have had civilizations once, now frozen ruins orbiting nothing, their stories lost to eternity. The vacuum of space may not be stable. Quantum field theory suggests our universe exists in a false vacuum, a metastable state that could decay to a lower energy state at any moment. If vacuum decay occurs anywhere in the universe, it would expand at light speed, destroying everything in its path. Matter as we know it would cease to exist. The fundamental forces would change. Atoms would unbind. There would be no warning. The bubble of true vacuum would arrive at light speed, meaning we'd cease to exist in the same instant we could theoretically observe it. This could happen at any moment. It may be happening now, somewhere in the universe, the bubble of destruction rushing toward us through space. There's no way to prevent it, no way to escape. If it reaches us, we and everything we've ever known simply stops existing. Some physicists believe this is the universe's ultimate fate. Others calculate we're stable for billions of years. But there's a non-zero probability it could happen tomorrow. The experiments we conduct, particle accelerators smashing matter at extreme energies, some worried could trigger vacuum decay. We literally cannot know if we're moments away from annihilation or if we have eons. The uncertainty itself is maddening. The universe may be fundamentally unstable, existence itself temporary. Black holes are where physics breaks down and horror begins. At their center lies the singularity, a point of infinite density where space-time curvature becomes infinite and our laws of physics cease to apply. The event horizon marks the point of no return. Cross it, and you cannot escape, not even light. But death in a black hole wouldn't be quick. You'd experience spaghettification. Tidal forces would stretch you, pulling your feet faster than your head as gravity's gradient increases. Bones would snap, organs rupture, your body stretched into a stream of atoms before reaching the singularity. But from an outside observer's perspective, you'd appear frozen at the event horizon forever, asymptotically approaching but never quite reaching it. Your image redshifted and dimmed over billions of years. Inside the event horizon, space and time swap roles. You don't fall toward the singularity. You fall forward in time toward it. An escape would require traveling backward in time. At the singularity, quantum mechanics and general relativity produce infinities. Physics doesn't know what happens. You might be crushed to infinite density. You might tunnel to another universe. You might cease to exist in any meaningful sense. Supermassive black holes at galaxy centers mass billions of times our sun. Sagittarius, a asterisk, at our galaxy's heart, could swallow our solar system whole. Stellar black holes form when massive stars collapse, each a wound in space-time. Space is filled with radiation that would kill us in minutes without protection. Cosmic rays, high-energy particles accelerated to nearly light speed by supernovae, pulsars, and black holes, constantly bombard Earth. Our atmosphere and magnetic field shield us, but in space, astronauts are exposed. Cosmic rays pass through spacecraft, through spacesuits, through your body. They damage DNA, causing cancer and cell death. On long-duration missions to Mars, astronauts would receive radiation doses hundreds of times higher than on Earth, despite shielding. Solar particle events, bursts of radiation from the sun, can kill within hours if you're caught outside during one. The Apollo astronauts were lucky. A major solar event occurred between Apollo 16 and 17. If it had happened during a moonwalk, the astronauts would have died. On Mars, with its thin atmosphere and no magnetic field, colonists would live underground or face constant radiation exposure and premature death. But cosmic radiation isn't the only threat. Vacuum itself is hostile. Exposed to vacuum, you wouldn't explode, but fluids in your body would vaporize. Your lungs would rupture if you try to hold your breath. You'd lose consciousness in 15 seconds from oxygen deprivation, die within 2 minutes. The cold would eventually freeze your corpse solid. Your body would drift in space, preserved perfectly by the vacuum, orbiting the sun or eventually falling into it, a mummified monument to human fragility. In the constellation Boötes lies a region of space 330 million light-years in diameter containing only 60 galaxies, a region that should contain 2,000. This is the Boötes void, one of the largest known voids in the universe. Most of it is utterly empty. No galaxies, no stars, nothing but sparse hydrogen gas and dark matter. If you were somehow transported to the center of this void, every direction you looked would show only darkness. The nearest galaxy would be tens of millions of light-years away, too far to see with naked eyes. You would float in absolute darkness, alone in a way impossible to comprehend. The void's existence challenges our understanding of cosmic structure. Why would such a vast region be empty? Some theories suggest the void formed from the collapse of negative mass or exotic matter shortly after the Big Bang. Others suggest it's simply a statistical fluctuation. But there's something deeply unsettling about such emptiness in a universe that should be filled more uniformly with matter. And the Boötes void isn't alone. The universe contains numerous supervoids, cosmic deserts in the web of galaxy filaments. These voids are expanding faster than the surrounding universe, growing emptier over time. Eventually, as dark energy drives cosmic expansion, the universe will become increasingly void-like everywhere, galaxies separated by ever-growing distances until each exists in its own isolated island of space, unable to see or contact any other. Gamma-ray bursts are the most energetic events since the Big Bang, stellar explosions that release more energy in seconds than our sun will produce in its entire 10 billion-year lifetime. When a massive star collapses into a black hole, or when two neutron stars collide, they can produce focused jets of gamma radiation traveling at 99.99% light speed. If a gamma ray burst occurred within a few thousand light-years of Earth and the jet pointed toward us, it would be an extinction-level event. The gamma radiation would strip away the ozone layer in seconds, exposing the surface to lethal ultraviolet radiation. Nitrogen in the atmosphere would be converted to nitrogen oxides, creating a brown smog that would block sunlight, causing global temperatures to plummet. Photosynthesis would halt. The food chain would collapse. Some scientists believe a gamma-ray burst caused the Ordovician extinction 450 million years ago, when 85% of marine species died. We've detected gamma-ray bursts from across the universe, on average, one per day. We're observing catastrophes that destroyed everything in their vicinity. The terrifying part is that gamma rays travel at light speed. We would have no warning. The burst and our annihilation would arrive simultaneously. We'd simply cease to exist, never knowing why. Several nearby stars are gamma-ray burst candidates. Eta Carinae, Betelgeuse. When they explode, if the jets point toward us, there's nothing we can do. We're at the mercy of stellar geometry. Everything we can see, stars, planets, galaxies, nebulae, makes up only 5% of the universe. The rest is dark matter and dark energy, substances we cannot see, cannot touch, cannot even directly detect, yet they dominate existence. Dark matter makes up 27% of the universe. We know it exists because its gravity affects visible matter and bends light, but it doesn't interact with electromagnetic radiation. It passes through you constantly, imperceptible. Dark matter particles might be colliding in your body right now, and you'd never know. We don't know what it is. WIMPs, axions, primordial black holes? Each theory has implications, none comfortable. If dark matter is black holes, trillions of them permeate the galaxy, invisible until something falls in. Dark energy is more disturbing. It makes up 68% of the universe and drives cosmic expansion to accelerate. Galaxies aren't just moving apart. They're moving apart faster over time. Dark energy is causing the universe to tear itself apart. We don't know what it is or why it exists. It might be the cosmological constant Einstein proposed. It might be a field permeating space. It might be something we cannot even conceive. The fact that 95% of reality is invisible and incomprehensible should be terrifying. We're living a universe we don't understand, made mostly of substances we cannot detect, governed by forces we cannot explain. We're infants trying to understand calculus. The moon is slowly leaving us, receding at 3.8 centimeters per year. Tidal interactions transfer Earth's rotational energy to the moon's orbit, gradually pushing it away. In the deep past, the moon was much closer. Early Earth had 5-hour days and experienced enormous tides that may have helped spark life. But the moon continues drifting away. In 600 million years, total solar eclipses will no longer occur. The moon will appear too small to cover the sun completely. In 2 billion years, Earth's day will be 25 hours long. Eventually, in tens of billions of years, the Earth and Moon will become tidally locked to each other, forever showing each other the same face, the Moon 30% further away than today. But humanity won't see this. The sun will expand into a red giant in 5 billion years, incinerating both Earth and Moon. Still, there's something melancholic about the Moon's gradual departure. The Moon stabilizes Earth's axial tilt, giving us stable seasons. It drives ocean tides essential to marine ecosystems. As it recedes, these effects weaken. In the far future, Earth without the Moon would be different. Wobbling axis, extreme climate swings, perhaps inhospitable to complex life. The Moon's retreat is imperceptibly slow, but inevitable. Every night, as you look at the Moon, it's slightly further away than the night before. The celestial companion that has watched over humanity's entire existence is slowly abandoning us, indifferent to our fate. Brown dwarfs are failed stars. Masses of gas too small to sustain hydrogen fusion, trapped between planets and stars, shining dimly in infrared from their heat of formation, slowly cooling over billions of years. They're common. There may be as many brown dwarfs as stars in the galaxy, but we didn't discover them until 1995 because they're so dim. These objects represent cosmic failure, potential never realized. They almost became stars, almost joined the great cycle of stellar life, but fell short. Now they drift through space, radiating waste heat, unable to shine. Some brown dwarfs have planets, worlds orbiting failed suns, receiving negligible warmth, frozen and dark. Could life exist on worlds orbiting brown dwarfs? It seems impossible. No light, barely any heat, just endless cold. Yet some brown dwarfs are warm enough to have habitable zones for a few million years after formation. Brief windows of possibility before eternal darkness. If civilizations arose on such worlds, they'd be born into twilight and watch their sun fade over millennia, knowing their doom was inevitable. They'd have to become spacefaring or die as their world froze. There's something deeply sad about brown dwarfs, objects that came so close to stellar glory but failed. The universe is filled with them, silent witnesses to what might have been. And beyond brown dwarfs lie even stranger failed objects, sub-brown dwarfs, planetary mass objects floating freely through space, never bound to any star, born alone and remaining alone. Near black holes and at high velocities, time itself warps. If you orbited close to a black hole's event horizon, time would pass slower for you than for the outside universe. Spend what feels like a few hours in such an orbit, and millennia could pass elsewhere. Return to Earth, and everyone you knew would be dead. Civilizations risen and fallen. Languages evolved beyond recognition. You'd be a time traveler cast into a future where you're alien. But you can't go back. This isn't theoretical. GPS satellites experience measurable time dilation, running faster than clocks on Earth by microseconds daily, requiring constant correction. Astronauts on the ISS age slightly slower than people on Earth, fractions of a second over months, but measurable. At extreme relativistic speeds approaching light speed, time dilation becomes severe. travel to a distant star at 99.99% light speed, and the journey might feel like months subjectively, but centuries pass on Earth. This creates a tragic dilemma for interstellar travelers. You could explore the galaxy, but never return home to the time you left. Your family would age and die while you're gone. Earth itself would transform. You'd be exiled in time, forever displaced from your origin. And near the event horizon of black holes, time dilation becomes infinite. From outside, objects appear frozen, taking forever to fall in. From their perspective, they fall normally, but see the universe age to its death in moments. Time ceases to be universal, becomes relative, fluid, weaponizable. When you look at static on an old television, about 1% of that static is radiation from the Big Bang, the cosmic microwave background, afterglow from the universe's birth 13.8 billion years ago. This radiation fills all of space uniformly, a nearly perfect blackbody spectrum at 2.7 Kelvin, just above absolute zero. It's the oldest light in the universe, released 380,000 years after the Big Bang, when the universe cooled enough for atoms to form and photons to travel freely. Before that moment, the universe was opaque, a hot, dense fog of plasma. The CMB shows us the universe's baby picture, tiny temperature fluctuations that seeded galaxy formation. But it also represents a barrier to knowledge. We cannot see beyond it. Everything that happened in the first 380,000 years is hidden from us, knowable only through theoretical physics and indirect evidence. The universe before the CMB is fundamentally inaccessible. We can never observe the Big Bang directly. There's something melancholic about this. The universe's origin story is forever beyond our reach. The CMB also reveals our cosmic isolation. It's remarkably uniform, meaning the universe looks the same in all directions. We're not in a special place. We're in an average location in an average galaxy in an unremarkable region of space. The universe doesn't care about us. And as the universe expands, the CMB redshifts to longer wavelengths, cooling further. Eventually, it will fade to undetectability, and future civilizations won't be able to see evidence of the Big Bang. They'll be cosmologically blind. The space race killed people, not just in accidents we know about, but possibly in secret missions that went wrong. The lost cosmonaut theory suggests the Soviet Union had failed missions they covered up, cosmonauts dying in space whose existence was erased from history. While evidence for most claims is dubious, we know the Soviets were secretive. Cosmonaut training groups had members who disappeared from records after accidents. Vladimir Komarov knew his Soyuz 1 spacecraft was flawed, but flew anyway. Refusing would mean his backup, Yuri Gagarin, would die instead. Komarov's parachute failed during re-entry. He fell from space, cursing the engineers who killed him. His remains required a closed casket. The capsule's impact crater was visible from orbit. Then there's the crew of Soyuz 11, Georgy Dobrovolsky, Vladislav Volkov, and Viktor Patsayev, who died during re-entry when a valve opened, depressurizing the capsule. They asphyxiated in seconds. The capsule landed automatically. When recovery crews opened it, they found 3 bodies, blood trickling from their ears and noses. Beyond confirmed deaths, space is filled with debris, defunct satellites, spent rocket stages, fragments from collisions. Among this debris are the ashes and remains of people who chose space burial. Their cremated remains orbit Earth in containers that will eventually burn up on re-entry. They're slowly falling, spiraling toward Earth's atmosphere where they'll become shooting stars. There's poetry in that, perhaps, but also something lonely about remaining in orbit, neither in space nor return to Earth. Io, Jupiter's innermost large moon, is the most volcanically active body in the solar system. A tortured world experiencing constant eruptions from tidal heating as Jupiter's gravity stretches and compresses it. Over 400 active volcanoes at its surface. Volcanic plumes shoot 300 kilometers into space. The surface is sulfur dioxide frost, colored yellow, red, and black from sulfur compounds. Temperatures range from minus 130 degrees Celsius in the shade to 1,700 degrees Celsius in lava lakes, hot enough to melt rock. The entire surface is constantly resurfacing. Nothing older than 1 million years exists. Any impact craters are quickly erased by lava flows. If you could stand on Io, you can't. The radiation would kill you. You'd see Jupiter dominating the sky, 40 times larger than the moon appears from Earth. But Io's violent geology would be impossible to ignore. The ground would literally be unstable beneath your feet. Sulfur dioxide geysers would erupt around you. The sky would be filled with volcanic plumes. You'd be standing on a world being torn apart by tidal forces, a world that will never know peace. Io's sulfur is stripped away by Jupiter's magnetic field, creating a plasma torus around Jupiter fed by Io's agony. In a sense, Io is being slowly devoured by Jupiter, its mass stolen particle by particle over billions of years. Eventually, far in the future, Io might be consumed entirely, reduced to a ring of debris, its volcanic fury finally silenced. Until then, it remains a volcanic hell, a window into the violent forces that shaped the solar system. On August 15, 1977, a radio telescope detected a signal from space so unusual that astronomer Jerry Emmon wrote, "Wow," in the margin of the printout. The signal lasted 72 seconds, was 30 times stronger than background noise, came from the direction of Sagittarius, and had the characteristics expected from an extraterrestrial transmission. It matched the frequency hydrogen emits, the frequency scientists predicted aliens might use to communicate because hydrogen is the universe's most common element. The signal hasn't repeated despite numerous attempts to detect it again. We don't know what it was. The most exotic explanation is an alien transmission, a civilization in Sagittarius sending out a beacon, perhaps announcing their presence, perhaps warning others. If so, the signal traveled hundreds of light years to reach us, meaning whoever sent it did so hundreds of years ago. They might be extinct now. Their world might be dead. We're receiving a message from ghosts. Or perhaps the signal was a one-time burst, an alien civilization's death scream as their star went supernova, their last moment of existence propagating through space forever. We'll never know. The signal hasn't repeated in 45-plus years. Whatever caused it, alien or natural, it's gone. We had one chance to detect something extraordinary, captured it, and then it vanished. The wow signal represents the universe's indifference to our curiosity. We can listen all we want, but the universe answers on its own terms, if at all. Venus is Earth's twisted sister. Similar size, similar mass, but its surface is hell. The atmosphere pressure is 92 times Earth's, equivalent to being 900 meters underwater. The atmosphere is 96% carbon dioxide with sulfuric acid clouds. The greenhouse effect created surface temperatures of 462 degrees Celsius, hot enough to melt lead, hotter than Mercury despite being further from the sun. Soviet Venera probes that landed on Venus survived only minutes before being crushed and melted. Photos they transmitted show a desolate landscape of rock under a yellowish sky before the landers died. The surface is volcanic plains dotted with shield volcanoes and strange features called coronae, circular structures possibly caused by mantle plumes. Venus may still be volcanically active. Lightning storms rage in the sulfuric acid clouds. Venus wasn't always hellish. Billions of years ago, it may have had liquid water oceans. But a runaway greenhouse effect boiled the oceans away. The water photodissociated by UV light. Hydrogen escaped to space, and Venus became the inferno it is today. This could happen to Earth. Venus is Earth's possible future if we mismanage our climate. Some scientists suggest Venus had life before the runaway greenhouse. Life that watched its world transform into hell over millions of years, powerless to stop it. If microbial life remains in Venus's upper atmosphere, where temperatures are tolerable, they're the survivors of apocalypse. eking out existence in sulfuric acid clouds above the ruins of their world. Titan, Saturn's largest moon, has liquid lakes and seas. Not water, but liquid methane and ethane at minus 179 degrees Celsius. In 2005, the Huygens probe descended through Titan's thick atmosphere and landed on its surface, transmitting for 90 minutes before its batteries died. It landed in a dry lake bed, but images show pebbles rounded by liquid flow and evidence of methane rain. Titan has a weather cycle like Earth, but with methane instead of water. Methane rain, methane rivers, methane lakes. The Kraken Mare, Titan's largest sea, is bigger than the Caspian Sea. Beneath this alien landscape might be a subsurface ocean of liquid water, kept liquid by radioactive heat, a water ocean beneath a methane sea. If life exists on Titan, it would be truly alien, metabolizing in liquid methane at temperatures that would freeze Earth life solid instantly. But what haunts me is the thought of Huygens, humanity's only probe to land on a body in the outer solar system. Sitting dead in a dry lake bed on Titan, its batteries depleted, its mission ended. Eventually, methane rains will come. The lake bed might fill. Huygens could be submerged in liquid methane, buried in sediment, becoming a fossil of human ambition on an alien world. In billions of years, when the sun expands and Titan warms, if intelligent beings evolve there and develop archaeology, they might find Huygens, an artifact from a vanished civilization orbiting a warming red giant, evidence that we once reached across the solar system before we died. Our galaxy is moving at 600 kilometers per second towards something called the Great Attractor, a gravitational anomaly 150 to 250 million light-years away in the direction of the Hydra Centaurus supercluster. We can't see it directly because it's hidden behind the zone of avoidance. The plane of the Milky Way blocks our view with dust and stars. But we know it's there because its gravity is pulling our galaxy and tens of thousands of other galaxies toward it. The Great Attractor itself is being pulled by something even larger. The Shapley supercluster, 650 million light-years away, containing tens of thousands of galaxies. Galaxies like beads on strings flow through space along these gravitational rivers towards superclusters. We're caught in a current, being pulled toward a destination we'll never reach. At current speed, it would take billions of years to arrive, but the universe's expansion means we'll never actually get there. The expansion of space will overcome the gravitational pull, and the Great Attractor will recede from us forever, unreachable. There's something unsettling about being pulled toward an invisible destination by forces we can't resist. We're passengers on a galaxy falling through space towards something hidden, and we can't change course. Even more disturbing, we didn't discover we were moving toward the Great Attractor until the 1970s. For all of human history, we were unaware of this cosmic current, and there might be other such structures we haven't discovered yet, their gravitational influence silently determining our motion through space. Neutron stars are stellar corpses, the collapsed cores of massive stars that exploded as supernovae. They pack 1.4 to 2 solar masses into a sphere 20 kilometers in diameter, making them the densest objects besides black holes. A teaspoon of neutron star material would weigh 1 billion tons. The gravity is so intense that if you fell to a neutron star from 1 meter above the surface, you'd hit at 7 million kilometers per hour. You'd be flattened to atomic thickness on impact. The surface is an iron crust under extreme pressure. Below that, neutrons are packed so tightly that matter enters exotic states, neutron superfluids, strange matter possibly containing strange quarks. At the core, physics becomes uncertain. It might be quark soup, it might be something we can't even theorize. Neutron stars rotate rapidly. Pulsars are neutron stars spinning up to 700 times per second, their magnetic fields channeling radiation into beams that sweep across space. If a pulsar's beam crosses Earth, we detect it as regular pulses, cosmic lighthouses sweeping the dark. But imagine standing on a neutron star's surface. You can't, you'd be crushed instantly. The gravity would distort your vision. You could see the back of your own head because light curves around the star. The surface would be mountainous. Neutron stars have mountains, but they're millimeters tall. Gravity permits no higher. Time dilation would be severe. Spend time near a neutron star and return to find the universe aged thousands of years. And if two neutron stars collide, they create a kilonova, an explosion synthesizing gold, platinum, and uranium, seeding the galaxy with heavy elements. The gold in your wedding ring was forged in a neutron star collision billions of years ago. Voyager 1 and 2, launched in 1977, have left the solar system and entered interstellar space. They're currently over 14 billion miles from Earth, still transmitting faint signals. Each carries a golden record, a message to the universe containing sounds and images from Earth, greetings in 55 languages, music from Bach to Chuck Berry. The records are instructions for any civilization that finds them on how to learn about humanity. But the Voyagers are traveling at 38,000 miles per hour, fast by human standards, but painfully slow cosmically. It will take 40,000 years for Voyager 1 to drift within 1.6 light-years of another star. The Voyagers will wander the galaxy for millions or billions of years, long after the sun has died, long after Earth is gone, long after humanity is extinct or evolved beyond recognition. They'll drift between stars in the great emptiness, silent and dark, because their power systems will have failed thousands of years before their first stellar encounter. If a civilization ever finds one, humanity will almost certainly be gone. The Voyager probes will be our tombstones, monuments to a species that reached out into the dark but couldn't survive to see its message answered. Or perhaps they'll be found when they're ancient relics, so old that the very atoms they're made of have been altered by cosmic radiation. Perhaps they'll be archaeological curiosities to a future civilization that evolved on Earth billions of years after us, who marvel that ancient beings once launched these primitive machines into space. The golden records will outlast everything we build on Earth. They're humanity's longest-lasting artifacts, silent ambassadors from a dead world. Beyond Neptune lies the Kuiper Belt, a region of icy bodies extending 50 astronomical units from the Sun. Pluto resides here, along with thousands of other dwarf planets and millions of comets. But beyond the Kuiper Belt, far beyond, lies the Oort cloud, a spherical shell of icy bodies surrounding the solar system from 2,000 to 100,000 Australian dollars. The Oort cloud is so distant that its outer edge is a quarter of the way to the nearest star. It contains billions or trillions of comets, frozen reserves from the solar system's formation, barely bound by the sun's gravity. Passing stars can gravitationally perturb Oort cloud objects, sending them falling toward the inner solar system as long-period comets. These comets take millions of years to orbit the sun once. Some are visiting the inner solar system for the first time since the solar system formed 4.6 billion years ago. The Oort cloud represents the solar system's true edge, diffuse, enormous, mostly empty. We've never observed it directly, only inferred it from comets' trajectories. If aliens exist in a nearby star system, their Oort cloud and ours might overlap, creating a shared region between stars. The vast distances involved make the Oort cloud a kind of cosmic ocean. Our solar system is an island. The Oort cloud is the beach, the last tenuous connection before the deep sea of interstellar space. Objects in the Oort cloud receive almost no light from the sun. They exist in near total darkness, frozen to a few degrees above absolute zero, suspended between our solar system and the void, waiting for a gravitational nudge to send them on a million-year plunge toward the sun's warmth. In about 4.5 billion years, the Andromeda Galaxy will collide with the Milky Way. Right now, it's rushing toward us at 110 kilometers per second. It's visible to the naked eye on dark nights, a faint smudge of light. But that smudge is an entire galaxy containing over 1 trillion stars, all moving toward us relentlessly. When the collision begins, the night sky will change slowly at first. Andromeda will grow larger over millions of years, stretching across the sky like a cosmic scar. Stars themselves are unlikely to collide. The distances between them are vast, but gravity will wreak havoc. The delicate spiral structures of both galaxies will be torn apart. Stars will be flung into intergalactic space, ejected from their home systems forever, condemned to drift alone between galaxies. Our sun may be thrown into a new orbit, perhaps far from the galactic center, perhaps closer. The constellations humanity has relied on for navigation, mythology, and meaning will dissolve. There will be no familiar sky left. Entire stellar neighborhoods will be rearranged. Planetary systems could be destabilized. Comet showers could rain down on inner planets. Extinction events may follow. After billions of years of chaos, the two galaxies will merge into a single elliptical galaxy, sometimes called Milkomeda. Star formation will slow. Gas clouds will be exhausted. The new galaxy will age and dim, quieter than either parent ever was. If any intelligent life exists then, human or otherwise, they will inherit a universe already growing old, watching the last great galactic dance fade into stillness. The collision is unavoidable. Gravity has already decided. Every atom in your body is riding a galaxy on a slow-motion collision course toward a future sky no one alive today will ever see. Not all stars belong to galaxies. Astronomers have discovered rogue stars, stars ejected from their galaxies by gravitational interactions, supernova explosions, or close encounters with supermassive black holes. These stars wander intergalactic space alone, surrounded by nothing but darkness for millions of light years in every direction. Some of these stars may have planets. Imagine a planetary system drifting through the void between galaxies, its sky completely black except for its own star. No neighboring stars. No galaxy band across the sky. Just a single sun in infinite darkness. If life evolved there, it would grow up believing the universe contains exactly one star. If that star dies, expands into a red giant, or collapses, there's nothing nearby to replace it. No new warmth. No second chance. Life would freeze or burn and end, alone and unnoticed. Some rogue planets don't even have stars. They drift cold and dark through intergalactic space, their surfaces frozen solid, temperatures only a few degrees above absolute zero. If they once belonged to stars, they were torn away violently. If life existed there, it would have died in silence, never knowing why its sun vanished. The universe is filled with these interstellar orphans, worlds and stars without homes, wandering endlessly through regions so empty that even radio signals could travel for billions of years without ever encountering matter. Loneliness, it turns out, is a fundamental feature of the cosmos. Everything you see in the night sky is a lie, or rather a memory. When you look at the stars, you are not seeing them as they are now. You are seeing them as they were. Light takes time to travel. The moon is 1.3 seconds away. The sun is 8 minutes away. The nearest star beyond the sun is over 4 years away. Distant galaxies are millions or billions of years away. Some of the stars you see tonight no longer exist. They exploded, collapsed, or burned out long before humanity ever evolved. Their light is still arriving, carrying the illusion that they are still there. The sky is a graveyard of stars whose deaths have not yet been visually acknowledged. Even worse, when you look deep into space with telescopes, you're looking closer to the Big Bang. At extreme distances, you're seeing galaxies as they were billions of years ago, during epochs when the universe was younger, hotter, more violent. Some of those galaxies have since collided, transformed, or disappeared entirely. There is no now in astronomy. There is only delay. If an advanced civilization on a distant planet were observing Earth right now from 100 million light years away, they would see dinosaurs. Humanity would be invisible to them. Likewise, if someone is watching us now from far away, they are not seeing you. They are seeing Earth long before you were born. The universe does not allow simultaneous awareness. Every observer lives in a bubble of outdated information, trapped behind the speed of light, forever reacting to events that already ended. Reality itself arrives late. There will come a time when astronomy is impossible. As dark energy accelerates the expansion of the universe, distant galaxies are moving away from us faster and faster. Eventually, they will cross a boundary where their light can no longer reach us. Not because it's dim, but because space itself is expanding faster than light can travel through it. One by one, galaxies will vanish from the observable universe. Future civilizations, billions or trillions of years from now, will look into the sky and see only their own galaxy. No evidence of the Big Bang. No cosmic microwave background. No expansion. The universe will appear static, eternal, small. All evidence of cosmic origins will be erased. They may conclude, incorrectly, that the universe has always existed as it is, that it contains only a single galaxy, that there was no beginning, no evolution, no cosmic history. The truth will be unknowable. We exist in a privileged era, early enough to still see the universe's structure, late enough to understand it. That window is closing. Cosmology itself has an expiration date. Eventually, the universe will forget it ever had a beginning. In the far future, long after galaxies stop forming stars, there will still be light, faint, rare, and precious. Red dwarfs, the smallest and longest living stars, will burn for trillions of years. Around them, if planets exist, life might persist long after galaxies like ours have gone dark. These stars flicker gently, barely changing, offering stability in an aging universe. But even they will die. Eventually, the last star will burn its final hydrogen, collapse into a white dwarf, and fade. After that, there will be no natural sources of light left. No stars, no galaxies, just cold remnants drifting apart. Any remaining beings would live in darkness, relying on artificial light powered by dwindling energy sources. Every photon would be accounted for. Every spark would matter. And then, even though it end, the universe does not rush toward its end. It stretches it out, thinning existence slowly, patiently, until nothing meaningful remains. Not with violence, with quiet. Astronomers have found stars that shouldn't be there. Some stars appear far older than the universe itself, at least according to their chemical composition. One such star, HD 140283, nicknamed the Methuselah star, is estimated to be over 14 billion years old. The universe is 13.8 billion years old. The math doesn't work. These ancient stars formed when the universe was still young, before heavier elements existed. They contain almost no metals, just hydrogen and helium, relics from a time when galaxies were still assembling themselves from chaos. They are survivors from an era long erased. They orbit the Milky Way not in its disk, but in long, looping paths through the galactic halo, passing through our galaxy like ghosts. They do not belong here. They predate most of what we see. The unsettling implication is this: our understanding of cosmic time may be incomplete. Either our measurements are wrong, or the universe is older, stranger, and more complex than we think. These stars have watched galaxies form and die. They have watched black holes grow. They have existed through epochs when the universe looked nothing like it does now. And they will likely outlive us. They burn quietly, indifferent witnesses to a universe that keeps rewriting its own rules. Our universe may not be unique. According to inflation theory, the rapid expansion that occurred moments after the Big Bang may still be happening elsewhere. In this model, space itself is continuously expanding, spawning new universes in an endless process known as eternal inflation. Each universe forms as a bubble. Inside each bubble, physical laws may differ. Different constants, different dimensions, different forces. Some universes may collapse instantly. Some may never form stars. Some may be filled entirely with radiation. A few, like ours, may be stable enough for galaxies, chemistry, and life. If this is true, then the Big Bang was not the beginning, just our beginning. Beyond our observable universe could be an infinite sea of other universes, forever unreachable, forever causally disconnected. No signal can cross between them. No proof can be obtained. This raises an uncomfortable thought. Everything we are, everything we know, may exist in a tiny pocket of a much larger reality, one that doesn't care whether our universe survives or not. Our universe could end tomorrow, and inflation would continue elsewhere, unaffected. We are not the center. We may not even be relevant. At the quantum level, reality behaves in ways that defy intuition. Experiments have shown that particles do not have definite properties until they are observed. Worse, entangled particles appear to influence each other instantaneously across vast distances, violating classical ideas of cause and effect. In 2022, physicists confirmed that the universe is not locally real. That means either objects do not exist with definite properties until measured, or information can travel faster than light, or reality itself is deeply non-intuitive in ways we cannot fully describe. There is no comforting interpretation. This suggests that the universe does not behave like a machine ticking forward predictably. Instead, reality is probabilistic, incomplete, and observer-dependent. At the deepest level, existence may not be solid. The atoms in your body follow rules that don't resemble everyday logic. The ground beneath you feels stable, but its fundamental components exist in uncertainty, flickering between possibilities. The universe is not obligated to make sense to us, and it doesn't. As the universe continues to expand, isolation becomes inevitable. Over trillions of years, galaxies drift so far apart that travel between them becomes physically impossible, even at light speed. Each remaining galaxy becomes an island universe, surrounded by unreachable darkness. Stars burn out. Civilizations, if they arise, are trapped forever within their shrinking pocket of matter. No visitors will ever arrive. No messages will ever be answered. The future universe is not dramatic or explosive. It is quietly lonely. An endless night where each surviving system exists alone, not because something destroyed the universe, but because expansion simply carried everything too far apart to touch again. There are events happening right now that we will never know about. Stars exploding, planets colliding, entire civilizations, if they exist, rising and falling. Their light is traveling outward, but the space between us is expanding faster than the light can cross it. Those photons will never reach Earth. These events might as well not exist to us. Reality, on a cosmic scale, is not defined by what happens, but by what can be observed. Most of the universe is already causally disconnected from us, unfolding its story in complete isolation. We live inside a small, shrinking bubble of knowable reality. There is a theoretical location in the universe where isolation becomes absolute. As the universe expands, galaxies beyond a certain distance disappear beyond the cosmic horizon. Eventually, any observer will be left with only their local group of stars, or even a single star. Imagine a future being living around a lone star in a dead universe. No other galaxies visible. No evidence of expansion. No cosmic background radiation. Their sky would be almost empty. They might conclude the universe contains only one star. They would be wrong, but they would have no way to know. Isolation would not just be physical. It would be epistemological. Knowledge itself would be constrained by cosmic geometry. Loneliness, at that point, would be baked into reality. Even space may not last forever. Some theories predict that space-time itself could decay, fracture, or transition into something unrecognizable. Dimensions may collapse. Constants may shift. The vacuum may change state. This wouldn't look like an explosion. It would look like nothing. One moment, the universe exists. The next, the concept of existence no longer applies. No aftermath. No ruins. No darkness. Just absence. Physics does not guarantee permanence. It only guarantees probability. In the far future, if intelligence survives at all, there may be only one observer left. A single mind, orbiting a dying star, drawing energy from its last warmth. Watching a sky with no galaxies, no structure, no story left to uncover. Eventually, even memory will become a burden. Without new information, thought loops inward. Identity erodes. And when the last observer fades, something profound happens. The universe continues, but no one is left to witness it. A universe without observers may still exist physically, but meaning collapses. No measurements, no interpretations, no awareness. Reality becomes silent. Noise is temporary. Stars burn briefly. Galaxies collide for a moment. Civilizations flicker and vanish. Even black holes evaporate. Silence remains. The universe spends most of its existence empty, dark, and quiet. Structure is an exception. Complexity is rare. We are living during the loudest, brightest, most interesting era the universe will ever have. And it is already passing. Everything yours is borrowed. The atoms in your body were forged in ancient stars. They wandered the galaxy for billions of years before assembling into you. They will scatter again. You are a temporary arrangement of cosmic debris, briefly conscious in an indifferent universe. And yet, here you are, thinking, listening, aware. The universe does not promise meaning, but it allows moments. This is one of them. The void waits patiently. It always has. In the far future, time itself becomes meaningless. Without stars, there are no days. Without orbits, there are no years. Without change, there is no way to measure passage. Civilizations that survive long enough will lose any natural reference for time. Seconds, minutes, and hours will exist only as abstract concepts inherited from a forgotten past. Eventually, even memory erodes. When nothing changes, time loses its function. The universe does not end with a moment of destruction, but with a gradual loss of structure, rhythm, and sequence, until existence becomes an unchanging stillness. If intelligent beings exist far into the future, they will live in a universe vastly smaller than ours. Their night sky will contain fewer stars. Their cosmology will be simpler, but incorrect, without evidence of expansion or background radiation. They may conclude the universe is static and eternal. They will be wrong, but there will be no way to prove it. All traces of cosmic history will have faded beyond observation. Knowledge itself becomes limited by physics. Truth exists, but cannot be accessed. The universe does not guarantee understanding, only survival. Even protons may not last forever. Some theories predict that all matter slowly decays, particle by particle, over unimaginable spans of time. If this is true, then planets, stars, and even black holes are temporary arrangements. Eventually, matter dissolves into radiation and leptons, leaving nothing solid behind. There is no explosion, no collapse, just a gradual thinning of existence. Structure gives way to simplicity. Complexity unwinds. The universe becomes smoother, emptier, and quieter with each passing epoch. The last sources of light in the universe will not be stars, but decaying particles and evaporating black holes. These final flashes will be weak and brief, scattered across immense darkness. After that, there is nothing left to illuminate space. No glow, no warmth, no reference point. Darkness is no longer the absence of light. It is the default state of reality. The universe does not fall asleep. It simply stops waking up. And so the universe settles into what it has been moving toward all along. Not chaos, but stillness. Not destruction, but exhaustion. Everything that could happen has already happened. Everything that could be remembered has faded. What remains is an infinite, silent expanse, where time has no meaning and distance has no purpose. There is no observer left to name it, no mind left to fear it. Just space, stretched thin and calm beyond comprehension. If you let your thoughts slow now, If you let the scale of it all gently recede, there is nothing left to do, nowhere left to go. The universe continues, indifferent, endless, and quiet.